let's try this. I'm going to make it just a little bit different. If I have 14 divided by the square root of 5 plus 2, my denominator is now a binomial. So when it comes to rationalizing, it's a little bit different. Okay. When I want to rationalize a denominator that is a binomial, we have to use the conjugate. Okay, we've already used that word today. It relates to the difference of squares. So what's the conjugate for this denominator? What's the conjugate? How would you multiply this times something to create a difference of squares?
Square root of 5 minus 2.
You would use the square root of 5 minus 2. And of course we have to do that in the numerator as well. Suppose you just did this though. A lot of students will try to do this. Will the square root of 5 times the square root of 5 simplify to something that's nice? Yeah, it just gives me 5. But you'd also have to multiply the square root of 5 times 2. Would that give you something where the radicals go away? No, so it would go away if you multiply it times this one, but you just create another radical here. So that's why I can't just do the square root of 5. But when I do its conjugate, the square root of 5 minus 2, what happens here in this denominator? That would give you the difference of squares. So that's the square root of 5 squared minus the other guy, 2 squared. So what is this? It's just going to be 5 minus 4, so that means it's just 1, right? So that means all of the stuff that I did here in my denominator just becomes a 1. I'm not saying that always happens when you multiply conjugates, but in this case 5 minus 4 is 1. What about your numerator? I distribute, and so what do you have?
You have 14, 5 cubed.
14 square roots of 5 minus
14 minus 2. 28.
So you get 28. Now, is this my final answer? No. So the final answer is just 14 square roots of 5 minus 28. Don't leave that over 1. Like if I say I'm 42 over 1 years old, that just sounds ridiculous, right? Won't you just say you're 42? No, Mr. Craig, actually I would say I'm 23. You know.
Like 6 years younger than I thought you were.
This one goes out. No, this one's dedicated to the one I love. 20 over the square root of 11 minus the square root of 3. I've got two radicals. I've got a binomial. What did I say you should do when you have a binomial down there? Create a difference of squares by multiplying times the conjugate. What's the conjugate?
The square root of 11 plus the square root of 3.
Square root of 11 plus the square root of 3 in this case, because I already had the minus part there. Okay. Now, in this denominator, what happens here?
The equals 1. So it goes away.
Square root of 11 squared minus the other square root of 3 squared. So what do we get here? 11 minus 3, which equals 8. Right? Now, here's what I want you. I want you to look ahead here. My denominator is 8. My original numerator was 20. Don't these guys have something in common? So before you distribute, I want you to do this. I want you to keep this guy factored for me. So that's 20 times the square root of 11 plus the square root of 3, and this is all over 8. Are you guys with me to that step?
Yes.
Once you're here, reduce before you distribute. So when I reduce, this guy becomes what?
The 8 moves 2.
4 goes into both of these. It goes in here 5 times and here twice. And then I'm just going to distribute the 5. So we have what? 5 square roots of 11 plus 5 square roots of 3 all over 2.
And you say we can't combine those because those don't have the same radicand.
They don't have the same radicand, correct. So they're not like radicals in the numerator. Okay. Just one more guy I want to show you, and then we can move on to some easier stuff. You'll like the next stuff better than this. Rationalizing denominators is always one of the worst things ever.
It's just.
Well, that's the thing with most algebra. There's a lot of detail. You get one thing wrong, and it leads to a world of problems. And when you go on to things, if you ever go on to, say, calculus, you may, the first step that you do in calculus is calculus. Every other thing that you do is algebra. Okay? And so if you've got good algebra skills, calculus really isn't that difficult. Now I've got this guy. Again, I have a binomial, and I've got radicals here. How do I go about getting rid of that and rationalizing that denominator? So I use the square root of x minus the square root of 2. Do y'all agree? Okay. Let's kind of scratch out what happens in my denominator here. This is the difference of squares. So I get the square root of x squared and the square root of 2 squared. So what does that give me? Isn't that just x minus 2? So all of that nastiness that you saw in the denominator is really just x minus 2. I've got a lot of junk in that numerator to multiply out, don't I? Do you see something neat, though?
Yeah, like terms.
Where?
Oh, I was just looking at the 2x minus 4 there, thinking that those were going to cancel. Never mind.
What do you mean? Well, there's not like terms, but there is something with 2x minus 4. What is it?
The x cancel out?
X's don't cancel, but there's a common factor of what?
2.
If you take out the common factor of 2, you have x minus 2, and then you've got this other stuff you'd still have to multiply in, right? But look at what I have. What can you do?
Cancel out the x minus 2.
You cancel out the x minus 2's, and so you really just have what? You have 2 square roots of x minus 2 square roots of 2. If you take that common factor and you distribute that to the square root of x minus the square root of 2. So when we factor this numerator here to give me 2 times x minus 2, it ends up reducing with that denominator once I have rationalized that denominator.
So
And I just took the 2 times that stuff.
So you're distributing the 2
Into those guys, yeah.
and it's multiplication, so you can actually.
Right. If that were addition, I couldn't do anything else. So this horrible expression became something that's really not too bad, and the things you'll see later on is a lot easier to work with like this as opposed to this.